Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called King's Salary. It's a medium problem. So I'll let you guys pause and go over the problem once. So just to explain the problem, basically we've been given this town, right? And in this town there's 66 total people living, out of which 65 are citizens, and there's one king, right, which is counted as the 66th person. Now, each year, salary is distributed, and the total amount of that salary has to add up to 66, right, which is given by the sign over here. Basically, the total amount, the salary must sum up to 66, right? Now, what the king does is he suggests a new salary plan for every year for every single person, right, including himself. And now the catch is that the citizens are greedy and vote yes if their salary is raised, no if decreased, and don't vote otherwise. Now, this is going to become a problem for the citizens in general, and we're going to understand how as we move forward. So, basically, for the king, his goal is, well, of course, he's selfish and clever, so his goal is to end up having the most salary possible. And for that, he's going to propose a series of such plans in order to slowly increase his salary, right? Now, the question is, what is the maximum salary he can obtain for himself? And remember that for his plan, his suggested plan for that particular year, by plan I mean the salary distribution for each citizen, for that to be implemented, the number of yes votes have to be greater than the number of no votes. And it doesn't matter the number of people who don't vote. This condition just has to be satisfied. So, in my opinion, the biggest in for this problem is that once you start playing around with the numbers, you'll soon realize that the optimum strategy for the king is to somehow reduce the number of salaried citizens. Well, why does this work? Well, since there's always only 66 total dollars to be split, and each of the citizens and the king, all of them are greedy. Well, it's only beneficial for the ones remaining that are being given a salary if the pool among which they are being having to split from is smaller and smaller. So in this at the start, the $66 are being split between all 66 people. But if we somehow reduce the number of people to, let's say, just 6 people, then we could. This is just rough figures right now, but we could hopefully split the dollars at least something around 11 for each of the 6 guys. So as you can see, by reducing the number of people that are being received a salary, we can increase the salary of those who are left, and among which one could be the king. So this is the initial thought process that would lead you to this hint. And another hint that I'd give you guys is, okay, so since our goal currently is to decrease the number of salaried citizens, the best we could do is to reduce the number to almost 1 by 2 of whatever it started with. So if we started off with 66 guys, then at best we could bring it down to 33 or 34 or some number around this number, right? Why? Because we need enough people to say yes to this new plan, and that the number of yeses have to be greater than the number of no's. And so if you think about it, for the first case, since we have 65 votes, because we're always going to have 65 votes because there's 65 citizens, right? Now what happens is, let's say the king sacrifices his own salary for now, and he gives 33 citizens $2 as their new salary, and for the rest of the 32 citizens, he decreases the salary from $1 down to 0. So these guys are gonna say no, but these guys, which are one more than this number over here, since 33 is 1 plus 32, these guys are gonna say yes. And what ends up happening is these 32 guys are now out of the picture since they said no, but the new plan has been implemented because of this rule over here. And what ends up happening is these 32 guys are gonna now stay at a salary of 0, and since they're gonna stay at a salary of 0, they're not gonna be voting for the next rounds. And now all that we're left with is the king with a salary of 0 and 33 other citizens each with a salary of $2. Now, again, try to think about the hint. Try to decrease the number of salary citizens, and at best, we can do that to almost 1 by 2 of the initial number. So, what the king does now is, since there's 33 people who are gonna vote, and to get a yes out of any citizen, try to think about it, and while still being greedy, what we can do is increase their salary by just $1. And if we're gonna get a no out of a citizen, then we might as well just bring him down to $0, because decreasing it by $1 or $2 isn't really the optimal approach. Well, since he's not gonna get the same amount of salary that as he used to get, he's gonna get a number that is lower, and he's gonna give a no for sure. Then you might as well just bring it down all the way to 0. So for these 33 people over here, what we could do is split them into 17 and 16. And for these 16 guys, he's okay if they vote no, and he wants yes from these 17 guys. So what's he gonna do? He's gonna take all these $32, which is basically 16 into 2, since each of these guys had $2 to start off with. He takes those $32. Since all of these 17 guys right now had a salary of $2, he'd either give now each one of them $3, or since giving each of those 17 guys $3 would still just cost us $17, so we'd still be left with $15. So you can also give them $4. So these 17 guys will now be promised either $3 or $4, and so they're gonna say yes, because that's an increase from the number 2 that was their initial salary. So now the equation looks like the king with $0 and 17 guys with either $3 or $4, right? And the process keeps on continuing. It keeps on continuing to the point where until we can keep on reducing the numbers by almost half, right? So what's gonna eventually happen is, if you can pause and think about it, we're gonna end up with the king having again $0 and 2 guys, right? So I'll just call them person 1 and person 2 with really big amounts, basically half of the entire. So let's just say it's $33 here and $33 over there. The actual figures could be something different, but the point is that the king managed to come down to only 2 people having basically almost half of the initial $66 salary. Now at this point, the king realizes that since the rule was the number of yes have to be greater than the number of no, he cannot anymore reduce the number of people. So now what happens, and this is where the king like betrays these 2 guys, right? So now what happens is the king calls in 3 guys with salaries of 0. I'll just call them P3, P4, and P5. And these guys could be any 3 of the guys that we betrayed earlier. So they could have been betrayed at any point. They could have been betrayed during the first round where we took away the salaries of these 32 people. The second round we took away the salaries of these 16 people. The point is, these 3 people now are at a salary of 0, right? Now what happens is, since the king knows that if these 3 guys say yes, and it doesn't matter if these 2 guys say no, then the king will be able to redistribute the salaries. And now what the king proposes is, the king says that I'm gonna take $63, you guys take $1 each, and let's take away all the dollars from these 2 guys. And this becomes the best possible distribution for the king, where he's getting 63 of the total dollars, right? And he's taken 3 lucky people to get $1 each, and all the others. So that would mean 62 other citizens would get $0. I hope you guys understood the solution. Basically, the thinking behind this was that we had to decrease the number of salaried people in each round. Eventually, you'd end up with only the king and 2 people that are having pretty high salaries. And at that point, you can just pick 3 guys with 0 salaries and give them $1 each to bribe their vote. And you can give all the 63 other dollars to yourself. So I hope you guys understood the solution, and thanks for watching.